Well, hi everybody. Let's go over Chapter 3 in the enVision Algebra 1 Common Core for Pearson book series. We're going to go through a bunch of problems like we always do, probably several wardrobe changes. These videos take about an hour, but let's get started. Which relation is not a function? Remember, a function means the x's cannot repeat. So look at these x values. Remember, every point is given to us as an xy. Well, this x value cannot be used twice in the same set. So see how 7 is used a whole bunch of times? You are not a function. And what am I looking for? Not a function. So it's A. Okay? You're used once, 4, 8, 12, 16, 20, 1, 3, 5, 7, 9. The answer is A. Done. Pretty easy. Now, with this guy, I'm being asked if it represents a function. I'm going to use what's called a vertical line test. So I'm going to make a vertical line and see if at any point my line hits my graph more than once. So I go beep, 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 and here I get nervous. But see that open circle? That means it doesn't count. See that open circle? That means it doesn't count. See that filled in circle? That means it does count. However, when my line crosses it, beep, 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 it beeps normally. Because my red line, my vertical line, only passes through that information once. So beep, 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 beep. So since my vertical line only hits my information at one point and one point only throughout the entire graph, does this represent a function? Represent a function? Yes, it does, baby. It's a function. Can't spell function without fun. Does this diagram represent a function? No. Because see that input? That's an x value. Inputs are x values. That input is going to two different numbers. So that x is being used twice. If I were to write these out as points, I would have 220 and I would have 240, which means 2 is used twice, which means this ain't a function. Nice, easy. Identify the domain and the range. The domain are the x values. So when I look at this and it says identify the domain and range, my domain is going to be 2, 3, and 4. I like to put things in order. And even though I use 2 twice, I'm only going to write it out once. My range is the output, and that's going to be 20, 30, 40. So my domain's always going to be the x values. My range is always going to be the y values. Easy. All right, location change and computer change. So if the dimensions look a little wonky, that's why. But no one ever notices. Who watches these? Like two of you. Is this a function? Well, as you remember from the last couple problems, if the x is only used once, and in this case the x seems to only be used one time, every x goes to its own y, yeah, this is a function. Okay, if you were to see something like this on a mapping diagram, that's when it wouldn't be a function, but it didn't happen. Didn't happen at all. So the next question is this one-to-one? Well, one-to-one means every x value has its own unique y value, which means x values definitely can't share, but the y values can't share either. And to answer this guy, the answer is yes. 10 goes to 15 and 15 only. 20 goes to 45. 30 to 25. 40 to 35. The output doesn't repeat either. So this is one-to-one because every x has its own y. So usually if I ask you if it's a function, I don't care how often the output or the range or the y value is used. But in this case, one-to-one means I do care a little bit now. And in this case, yeah, it is one-to-one. Sasha sells t-shirts. Each day she earns a set amount plus a commission. Write a linear function f to determine Sasha's pay. All right, I'm going to do this on, let's do Desmos. I'll do this on Desmos, so I'll stop, do Desmos, come right back. All right, so for this guy, I have to find the line or the equation of this formula, and I'm going to use Desmos to do it. So let's open up a table. Let's type in what we know. We know that we have x values of 1, 2, 3, 4, 5. Once something officialized, I don't remember how it goes. Let me check my values. I got 68, 71, 74, 77, 80. Okay, don't see any points there, so let's zoom fit so now that I can see points. In my second line, let's get rid of u. In my second line, let's type out y equals mx plus b. I'm going to add a slider for all. And my line definitely is a perfect straight line going through these points. This is 100% a linear equation. But it looks like my y-intercept is way up at 65. So what I'm going to do is I'm going to have my b, I don't know, in between 0 and 65. Well, let's do 70, just to be on the safe side. Step. Let's do 5. Let's go by 5s. So I can move my slider up to 65. There you are. That doesn't give me a right slope, but it looks like my y-intercept is going to be spot on. Let's increase that slope. Let's increase that slope until I definitely get it through all of them. I lost it. So now I definitely have an equation of y equals mx plus b, where m is 3 and b is 65. So just because I'm a paranoid little boy, I'm going to type it out. Y equals 3x plus 65, and in a second that green line will turn red or blue. I can't tell colors, but regardless, it turned blue because I just covered what I made here in red. So that's it. That's my equation. All right, so I have to write this out. Usually I write it out as y equals mx plus b, but I have a few substitutions. So instead of y, we are going to do f. And I could use f of x. I could use f of t for t-shirts. But f of x will keep it somewhat consistent. The slope, according to Desmos, was 3. And then the y-intercept of the b, according to Desmos, was 65. Which, according to the problem, basically means she gets paid an extra $3 per shirt, and she started out with 65 bucks. That's not what the question was asking, but that's a linear function f to answer that question. Okay? Thank you, Desmos. Thank you, Desmos. Find the function rule and predict the total charges for 100 minutes. Let's use Desmos again. All right, so we're going to use Desmos again. Let's bring out our table. We started out at 20, 30, 40, 50, and 60. 60, and I believe it was 17.5, so let's do that. 17.5, and then it was 20, and then it was 22.5, and then it was 25, and then it was 27.5. I don't see my points, so let's zoom fit to now I can see my points. It looks like my y-intercept is going to be somewhere around like maybe 13. So let's make another line. Y equals mx plus b, where I'm going to add a slider for all. My my y-intercept, I'm going to move up to 15. So I'm going to change it from like, I don't know, 10 to 15 to 15. And I should be able to move my slider up and down. Although, what I probably wouldn't, well, let me move it up a little bit. What did I predict? 13, so let's move it up to 13. 13, 13, 13. Wow, that's very picky. Hey, I could be wrong with a 13. But let's choose an M up. Yep. Oh, it's steeper. Hold on. So I'm not happy with the M's that I'm getting. So let's go over here. Let's make my step 0.25. See if that does anything. And that gives me a slope that makes me happy. So let's move my y-intercept down, 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 down. 12.5. I like it. So, like I said before, I'm a paranoid little boy. My slope is going to be 0.25x plus 12.5. Watch it turn green. Or watch it turn purple. I'm so bad at colors. That's that. Now, with these, we could use TI-84 pluses, which might not be a bad idea. Probably even a better idea. But, you know, this works too, if you know what you're doing. All right, so the equation, when I type it out in Desmos, I make it as y equals mx plus b. I'm going to keep my letters consistent. My x's are normally on the left, my y's are normally on the right. So when I rewrite all of this stuff out, I'm going to replace m with x, or x with m, and I'm going to replace y with t. So t equals 0.25. Instead of x, I'm going to put m plus 12.50. Basically what this means in this really ancient problem about cell phone charges by minute, my total charges is going to equal 25 cents a minute, plus I definitely have to pay $12.50 no matter what. The question that's being asked is predict the total charges for 100 minutes. So m is minutes. So I'm going to do t equals 25 cents. Don't know why I said it that way. I'm going to replace minutes with 100 because that's what the question is asking, plus 12.50. Okay. 25 cents times 100 is $25, plus 12.50 is going to equal 37. Can I make that 3 look like a 2? No, I'll just write it over here where I have more room. $37.50. So some of you may like look at this guy over here and say, can I just use common sense and go up $2.50 another 4 times? Sure, that's how I can do it in my head. But, you know, we're going to do some Desmos practice. We're going to do some LinReg practice on TI-84 pluses on this video and, you know, deal with things that way. So that's that. That's 8. Problem 9. Given f of x equals 4x minus 6 and g of x equals f of 2x, write an equation for g. All right. F of x is 4x plus 6. So g of x has me taking f of x and plugging in 2x for every x. I completely missed the x. So basically, f of 2x means I replace every x with 2x. So instead of 4 times x, I'm going to write out 4 times 2x minus 6. That gives me 8x minus 6, and that's it. That's my answer. So g of x is 8x minus 6. Nothing to simplify there. I'm just rewriting a function where I replace every x value with 2x. Let's not overthink it. Let's not overthink it. Next one. For f of x equals negative x plus 8, which statement is true? Okay. F of x plus k means if I were to rewrite that out, f of x plus k has me rewrite f of x but replace every x with x plus k. So negative x is now negative parentheses x plus k, and the parentheses and the x plus 8. So let's simplify this a little bit. I have all these colors over here. Let me use it. Okay? I'm going to have to write out f of x a bunch of times and then replace f of x. So I'm going to say I have to find out f of something. And so f of something equals negative something plus 8. So f of something equals negative something plus 8. I'm going to do it again. F of something equals negative something plus 8. F of something equals negative x plus 8. And last but not least, f of something, too much. F of something equals negative x plus 8. This computer's a bit laggy. Not a fan. Not a fan. All right. So let's plug in x plus k. See what happens. X plus k. Okay. Distribute the negative. So negative x minus k plus 8. Is that the same thing as f of x plus k? No. So it's not a. F of x is negative x plus 8 plus k would add a k to it. That's not it because that's minus k, so that didn't work out. X minus k, let's get a different color in here. X minus k, distribute the negative, so that becomes negative x positive k positive 8. So f of x is negative x plus 8, negative x plus 8 plus k. Nope, that's minus k. It's not b. It's a tricky one. I don't like it. I don't like it. I can tell you right now it's not c. So let's do d. F of x minus k is going to be x minus k. Distribute the negative, negative x. Distribute the negative, positive k plus 8. So I have a negative x, I have a positive 8, and I have a positive k. It's D. Ugh, I didn't like it. Didn't like it. The reason why I skipped C is because C would take too long because you're doing 2 functions, and that would give you a double 8. That doesn't happen here. That doesn't happen here at all. Tricky. If g of x is 2x, write an equation that moves g of x down 5. Okay, well, if I wanted to take any equation, okay, f of x, put some imaginary slope out there, okay, something like this. I'm just literally making it up, okay? Why did I put k there? I'm literally making it up. We'll make that k a 1. If the number inside the parentheses is negative, go right. If the number inside the parentheses is positive, go left. It's opposite of what we're used to. If the number outside the parentheses is plus 1, in this case, you go up. If it's minus 1, you go down. I need it to go down, which means I don't care about it moving left or right. I'm not going to do anything to x inside of a parentheses. So in order to just take an object and move it down 2, I take the original guy and move it down 2 by subtracting, down 5. Down 5 by subtracting 5 from everything. So that's what happens here. Minus 5. I don't know where I came up with 2, probably because I was staring at that the whole time. 2x minus 5 takes 2x and moves it down 5. Okay, nothing crazy about that one. If I give you 3x, and I want to write an equation that moves it left 3 up 2 and makes it 2 times steeper, this is what I'm going to do. If it's f of x equals a slope m stuff plus stuff. If I'm going to make it 2 times steeper, I'm multiplying my slope by 2. If I'm going to move it left 3, I'm going to add 3 inside the parentheses. And if I'm going to move it up 2, I'm going to add 2 on the outside. So what 3x is going to look like is 3 is my slope. So now what I have to do is I have to make it 2 times steeper. So 3 times 2 is 6. I'm going to take my x, wrap it in parentheses, and if I'm going left 3, I'm going to add 3 to it. So x plus 3. If I'm going to make it 2 times steeper, I already did that. If I'm going to move it up 2, I add 2 on the outside. Now I have something that's 2 times steeper, move to the left 3, and up 2. Weird. I like it though. Which of the following is an arithmetic sequence? An arithmetic sequence means you have to add or subtract the same number to get to the next term. So if I were to look at this, I add 2, I add 3, I add 4. That number is changed every single time. That's not arithmetic. I add negative 3, I add negative 3, I add negative 3, I add negative 3. That is arithmetic. I wonder if this is a select all that apply, so I'm going to keep going. Subtract or add negative 12, add negative 12. Oh, no, add negative 12. Oh, wait, no. That's subtract 24, subtract 12, subtract 6. No. Add 11. Definitely not add 11. So, yeah, this wasn't a select all that apply. This was just the answer is B. Done. All right, so the recursive formula is A sub n equals A sub n minus 1 plus D. N stands for the term, the nth term. If I'm just writing out a formula, I don't know what term I'm talking about. A sub n minus 1 is the previous term. I don't know what the previous term is, so I'm going to write out A sub n minus 1, and D is my common difference. That's what I can find. Now, the way I get from one number to the next each and every time is I add 4. So my common difference is positive 4, which means I add 4. That's it. That's my formula. Seems like it should be a little bit more complicated, but it's not. Okay, so that's it. Now, in this one, I have to write out the explicit formula. Now, the explicit formula, which means it involves more cursing, is A sub n equals A sub 1 plus D times n minus 1. So I have to write a formula, and then I have to find the 18th term. That's going to be fun, but I have calculators. What do I know? I know A sub 1 is the first term, so that helps. I know that every time I get from one number to the next, I subtract 2. So the formula is going to be A sub n equals 9.5 plus D times n minus 1. Oh, and I know D. D is negative 2, so let me fix that. D is negative 2, so let's put that in there. So I could probably put minus 2 instead of plus negative 2. That would look a lot better. That's my answer, and I'm sticking to it. Now, it wants me to find the 18th term, which means n is going to be 18. So I'm going to say A sub 18 is going to equal 9.5 minus 2 times 18 minus 1. PEMDAS says 18 minus 1 is what I do first. So minus 2 times 17. That's a 2. It's an ugly 2, but that's a 2. PEMDAS says I do multiplication before I add, so 9.5 minus 34. And that's going to end up being negative 24.5, I think. I'm sticking with it, not changing a thing. Not changing anything. Aerosmith said, I don't want to miss a thing. Well, I don't want to change a thing. I'd sing that song, but I don't want to get flagged for copyright. Each day at the bakery, Jack bakes cakes. Good for you, Jack, and helps out at the counter. Make a scatter plot of the hours Jack spends at the counter as a function of the number of cakes he bakes. Draw a trend line. All right, so 2 cakes, 4 hours. 3 cakes, 4 hours. 5 cakes, 1.5 hours. So let's put that right there, right in between. 6 cakes, 2.5 hours. So in between. 7 cakes, 1.5 hours. My trend line is going to be a line that fits as snug in the middle here as humanly possible, so maybe something like that. Probably could have done a slightly better job. I like it. That works. That works. Definitely a negative correlation. Not a perfectly straight line, though. But I like it. I like it. All right, boys and girls, we have a location change. I'm going to use the TI-84 Plus calculator to completely do that problem. So I'll split the screen, take it away, and then move on to the next problem. All right, so I am going to plug those points into my TI-84 Plus calculator. The first thing I'm going to want to do is go to Stat, Edit. So you hit Stat right away, Enter right away, and you get basically something similar to what you see. You have an L1, which would represent the X values, and an L2, which would represent the Y values. So 2, 3, 5, 6, 7, 8, 9. 2, enter 3, enter 5, enter 6, enter 7, enter 8, enter 9, enter. Okay, go to the right. And you've got 12, 10, 10. So let's do that. 12, enter, 10, enter, 10, enter, 8, 9, 5, 6. So 8, 9, 5, 6. And then make sure you have everything you need. I like to quit, so second mode. Go back to Stat. Go over right to Calc. Go down to 4, or just hit 4 for LinReg. Hit Enter. And then go down to Calculate, or just hit Enter a bunch of times until you get Calculate. And there you have it. That's the line of best fit. So it's a mess, for sure. But, you know, if I'm going to just write it out the way I need to write it out, I'm going to write out y equals y. Uh-oh, is this not working? Oh, I know why, because I'm using my screen, dummy. Y equals, what was it? Negative 0.86x plus 13.48. All right, so not pretty, not at all, but that'll do it. All right. Now I'm going to describe the slope and the y-intercept. So basically, it looks like I have a word problem or a fake word problem where I'm given temperature as my x-axis, sales as my y. And it appears to me that as temperature increases, the sales increase as well. So if we want to be hyper-specific, which I'm going to be because why not, I'm going to keep my line of best fit going a little bit further. And so what my y-intercept is going to be is at 10 degrees Celsius, my sales are going to be, that looks so sloppy, like a $100-ish, $110. Okay. Again, my y-intercept is that point, like right there. Okay. So at 10 degrees, I'm selling about $110 of whatever it is that I'm selling. That's the y-intercept. The slope, and it's all going to be a basic prediction. Nothing's perfect here. Is I'm just going to pick that part of the line and that part of the line, because why not? I can. And it looks like I go up maybe about half of a block. So my slope is going to be rise. So $50. So half a block. Each block, as you can see, is $100. So by going up half of a block, I'm saying going up 50. And by going over a full block, that's 2. So 50 degrees over 2, or $50 over 2 degrees is going to be $25 per 1 degree. So what I'm going to say is my slope is, as the temperature increases a degree, I can plan on selling $25 more. So as the temperature goes up by a degree, I'm planning on selling $25 more. That's what I'm going with. Okay? Okay. Predict the sales if the temperature was 21 degrees. Here's 21. There's no dot there. But what I'm going to do is I'm going to use my line of best fit, go up to 21, and put a dot right there. And that dot seems to be right under this line. So I'm going to follow it, I'm going to follow it, I'm going to follow it. And I'm going to say, I don't know, $475, maybe $480. It's predicting. We're not looking for an exact answer. So anything barely under $500 should really do the job. That's how you do that guy right there. Not so bad. Now with this one, I'm going to split the screen again. Although no, I don't. I don't have to do anything on my calculator. I was getting ready to do something on a calculator, but I don't need to here. The correlation coefficient, that is a positive strong correlation, is anything that is very, very, very close to 1. So if R is close to positive 1, that is the strongest of positive correlation coefficients, which means C, because C is awfully close to 1, because 0.997 is basically 1 if you round it up a little bit. Do the data show a positive or negative correlation? Can the data be used to show causation? Okay. So I have test scores for 6 students. So student number 1 got a 78 and an 85 in math. 79, 87, 83, 89. So this is what it's looking like. As the history numbers go up, the math numbers go up too. So both sets of data go up at the same time, which would make this a positive correlation. Wow, the handwriting is very laggy today, very sloppy today. Must be running too much stuff. Can the data be used to show causation? I mean, is it safe to say that somebody who does better in history does better in math? I mean, according to the data, I would say, yeah. I mean, their test scores being, with 6 kids, and this kid has an average score, gets a B. And as every kid does better in history, they do better in math too. And it's all has to do with the same thing. So it's all related material. It's not like I'm talking about history and hair length. It's history scores and math scores. So it's all about academics. I would say yes, that we have causation here. Now, what causation means is it safe to say that if somebody does better in math, that they'll do better in history? According to this data, yeah, it looks like it. It looks like it. So, causation, yes. The crazy hard ones. Let's get right to it. What correlation does the data represent? Find the equation for the line of best fit. So I have years of college and yearly income. So basically what's happening is this person did all this data, and somebody who didn't go to college makes that much money a year. Somebody who went to 1 year makes that much money a year. Somebody who went to school for 2 years makes that much money, and so on and so forth. It seems to me as somebody goes to college more, they make more money. So what correlation does this data represent? That's a positive correlation. Again, very laggy pen here, not happy with it. So even if I write as fast as I can, that's what positive looks like. I'm going to pause this, and then I'm going to do the next part on the calculator and then finish the rest of the problems. All right, I have to put that information into my calculator. So here's my calculator. If you want to clear your calculator, hit second plus 712. That's what I just did. And now we're going to put that data and make myself a LinReg problem. Hit stat first, edit by hitting enter right away. And on the left side, I have 0, 1, 2, 4, 6, 8, 10. 0, enter, 1, enter, 2, enter, 4, 6, 8, 10. Okay? No mistakes. Not that I noticed. I'm going to go to L2. So I hit the right button to get myself to L2. I hit the right button to get to L2. And now I'm going to type 34,736, 34,736, enter to get down, 38532, 38532, enter, 41184, 41184, enter, 57,252, 57,252, enter, 68,952, 68, what was it? 952, 82, 732, 82, 732, enter. And then somebody went to college for 10 years is 85, 228. All right, all of my numbers are in. Second mode quits out. All right, I'm going to hit stat. I'm going to go to calc. I'm going to go down to LinReg, or just hit the 4 button. Go down to calculate, 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 enter. And there it is, gross. Something's not right there. No, that's right. No, take it back, that's right. So let's round these to the nearest 10th because I got kind of nice numbers here. Let's write out that I have y equals, okay, y equals 5592.5. So we'll write that out, 5592.5x. And there's my face right there. That looks awful. Can I move that? Can I move my face? Can I move my face? And then plus 33606.99, so we'll do 33607. 33607. So basically what this information is telling us is that's my slope. So you can expect somebody to make a little around $5,500 per extra year of college. And that's somebody who never went to college, made around the $33,000 mark, which is what we're seeing here, give or take. Okay, so let's use that guy to probably answer a few more questions. Bye. All right, I'm back. Hi. There's my terribly written number, which is 33. It's a 3. Very laggy my computer is today. All right. So I have that information saved on my calculator. Let's start using it if I have to. Estimate the yearly income of someone who went to college for 5 years. So the equation that I wrote down was y equals 5592.5 x plus 33607. Okay? 5 years of college represents the x value right there. So I'm going to type this into my calculator, 5592.5. I'm going to replace x with 5, and then I'm going to add 33,607. And that would be a good estimate. So 5592.5, this one. 5592.5 times 5 plus 33607. I mistyped that out. I'm just going to use this. 5592.5 times 5 plus 33607.
It's 61,569.5.
Much easier. 61,569.5. So we'll add 0.50 for that 50 cents in the club. There you have it. That's our estimate. Okay. Find the residual value for 4 years of college. All right. What the residual value is you take the actual value, use the equation that you got, which was 559. So I'll write it out again. Y equals, but instead of x, I'm just going to say 5592.5 times 4 plus, what was it? 33607 plus 33607. Let's see what I get. 5592.5 times 4 plus 33607.
That would be 55,977.
So what I do is I take my actual point, I subtract that guy. So 57252 minus 55977.
The answer is 1,275.
And that's my residual value. Yeah. Yeah, I like it. Does this data imply causation? Is it safe to say that when you go to college for more years, you make more money? Yeah. Yeah. That's it. Big video. Don't know how long it's going to be, but I had a lot of fun. So thanks for watching. Love you. Bye.